Hello class, today we'll be looking at Radix Sort. Okay, it's a linear sorting algorithm different from comparison sorting algorithm that we've been talking about before, like those quick sort, those selection sort, those insertion sort, those bubble sort. Those are comparison sorting algorithm. This one is gonna sort in a kind of linear time complexity. All right, so you would repeat the distribution of the elements into buckets based on each digit value. So now let's see this example. You have this value, right? So you're going to sort this least significant bit right here. Then you move on to the middle. Then you move on to this guy. At the end of the day, when you finish sorting each of these lines, you would have sorted the numbers, all right? So you can see what's going on here. Here we sort this, we get this. We move on to this guy, we sort this, we get this. Move on to the guy, we sort this, and this is the value. This is the original element in the array, and this is the sorted list. All right. Now, Radix Sort works by sorting each digit from the least significant digit to most significant digit. So in base 10, the decimal system, Radix Sort would sort by the digits in the ones place, then the tens place, then the 100 place, then the 1000 place, and so on and so forth. All right. Let's see an example. You find the largest element in the array, which is 802. Why did we say 802? Because we are looking at this guy. This is the array. The largest here is 802. You see that? Now, you can see that it has 3 digits. So we iterate 3 times, once for each significant place. So we'll start from the unit to the tens and to the hundred, because 802 we have 2, we have 0, and we have 8. All right. So that's the idea. So you can see this right here. This, you see this underline here, that's to tell you where we are sorting at the moment. Take note that this is 802, right? Whereas this is 24. So this guy doesn't have the 100 value, so it's going to be 024. So when you are considering this 8, this guy will be 0. I mean, this guy's own 100 unit position will be occupied by 0, right? Then this guy will be occupied by 0 as well. Whereas this guy will be occupied by 1. So that's how you sort. So we sort the least significant, and you get this. Move on to the next, right? So you sort the middle value. The middle value of this 2 is going to be 0. So 2 will be 002. See that? Then you sort that, you get this. You move on to the most significant, which is the first value. This is 8. You sort based on this guy, and this is what you get. You see that? So this is the final sorted list. The same approach is what you see here. You pass this value, you sort based on each of the lines, and at the end of the day, you get this. You see that? Look at the code. You see this code? It's already sorted. Then look at this for loop. Then look at all these multiple for loops that seems to be nested by this outer for loop. This outer for loop is counting the number of significant places from the least significant to the most significant. And for each of those significant place, you take all the values that you can get from the list, then you perform counting sort on each. All right. So this is what the time complexity will be. So at the end of the day, the time complexity will be kn, right? Where k is like where you are counting the number of significant bits. Then n is what counting sort will give you. All right. So that's it with respect to Radix Sort. All right.